Hey Ramblers, this video covers chapter 9.2 in our textbook and introduces us to some of the important concepts of circles. Circles have so much vocabulary and different parts and angles and segments that the book does a good job kind of breaking that information up. So 9.2 is going to introduce us to circles. It's going to review area and circumference and probably some terms you know like chords, diameters, and radii. And then they're going to get into arcs, sectors, and arc length and arc measure. So a lot of information. It's really more of a vocabulary lesson than it is, how to do math. So you really need to take good notes on it. And good luck. All right, thanks for watching. Circles are probably one of the first shapes you ever learned about when you were a little kid. They're so common, and yet there's so much misconception about them. So let's start off with the definition of a circle. A circle is a set of points equidistant from a given point called the center. So it begs the question, is a circle more like a hula hoop or like a frisbee? Well, this ring here is the set of points that are equidistant from this center O. So that should be the circle. Yet many people are misconceived and they think that this blue portion is a circle, and it's not. So a circle is like a hula hoop, not like a frisbee. Okay, let's take a look at some of the important segments in a circle. The first is a radius. A radius is a segment from the center of a circle to the circle. Now, it's important in calculating the circumference and the area, as we'll see in a minute. Chords are also important segments related to a circle. AB is a chord because its endpoints are on the circle, as is what the definition is. Finally, we talk about diameters. A diameter is just a chord that passes through the center, which makes it the longest chord. We know a diameter as the distance across a circle. Okay, two important calculations, which are probably review for you, is circumference, which is the distance around a circle, and then area, which is the amount of space inside the circle. So, if I were to calculate the area, it would be this blue region would be a picture of the area, but not a picture of the circle. I hope you can understand the difference. Okay, so let's take a look then at what an arc is. Okay, AB is an arc because an arc is made up of 2 points on the circle and all the points in between them. So arc AB is A and B and all the points that are highlighted in between. To find the arc measure, we simply find out the number of degrees out of 360 that the arc occupies. I can measure this arc. No, I can't. We have to be told the measure of an arc or be given a way to figure it out. More will come on that in chapter 10. Arc length is the length of the arc, and so it's a fraction of the circle's circumference. To calculate arc length, we take the arc measure, divide it by 360, and that will give us the fractional part of the circle that the arc takes up. We then multiply that by the circumference calculation of 2 pi r. Sectors are closely related to arcs. A sector is a region bounded by an arc and 2 radii. It's kind of like a piece of pie or a piece of pizza. There isn't any fancy symbol for a sector, so you have to write out the word sector. So we would call AOB a sector. It's named by its 2 endpoints that are on the circle and by the center of the circle. To find the area of the sector, we take the arc measure divided by 360, just as we do for arc length, but this time instead of multiplying by the circumference, we multiply by the area of the circle. And that's how we find the area of the sector. Okay, the last topic is inscribed angles. Now, inscribed angles are angles whose vertex is on the circle. Angle ACB is an inscribed angle. To find the measure of the inscribed angle, it's 1/2 the measure of the intercepted arc. So angle ACB would be 1/2 the measure of arc AB. Okay, when they talk about intercepted arc, they refer to an arc that is in the interior of the inscribed angle. So AB is an intercepted arc. Okay, Ramblers, there's a couple of tutorials that I have attached to this, and then we'll conclude the video. Alright, one of the things that they ask us to do in this section is to find the measure of an inscribed angle. And as you recall, an inscribed angle is an angle that has both of its endpoints intercepting an arc, and its vertex is on the circle. So I could say that angle ABC is an inscribed angle. Now you may remember from the video that the formula for finding the measure of an inscribed angle is 1/2 the intercepted arc. Now the intercepted arc is arc AC because that is the arc whose endpoints meet the sides of the angle and whose points on the arc are entirely within the interior of the angle. So angle ABC is 1/2 of arc AC. So you would need to know how big arc AC was. And just for example, let's say it's 42 degrees. So that will make the measure of angle ABC 1/2 of 42, or 21 degrees. Okay, when we're looking at a circle, we sometimes have to figure out the measure of an arc. So let's say we have 2 points A and B, and the points between them form arc AB. And you may want to know what the measure of that arc is. Well, an arc is a portion of the circle. So let's say that we're told that angle ACB is 30 degrees. Then, since I know an inscribed angle is 1/2 the length of the arc, AB would be 60 degrees. I'm sorry, the angle is half the measure of the arc. So AB would be 60 degrees. That's the measure. To find the length, we would need to know the circumference of the circle. So we'd have to measure, or we'd have to know the radius. Let's imagine that the radius is given and that OB is 6. Then we could find arc length because it would equal 60 over 360 times 2 pi times the radius of 6. All this would equal just 2 pi when you multiplied it out. Keep your answer in terms of pi because it's exact. Now suppose that we were to find the area of the sector. Well, you may be reminded that a sector is a portion of the circle made up of an arc and 2 radii. So this shaded area would be a sector. And so that would equal 60 over 360. But this time, instead of multiplying by the circumference, we multiply by the area. So it will be 6 squared pi. So we get 36 pi over 6, or final answer is just 6 pi. And that would be the area of the sector. So 2 different calculations, but they're 2 really closely related calculations. Arc length is the fraction of the circle times the circumference, and the area of a sector is the fraction of a circle times the area. Okay, thanks for watching. Good luck.